In this lesson, we'll be going over potential, kinetic, and mechanical energy. Starting off, potential energy is the energy that an object has based on its height relative to the ground. Let's take a look at these three diagrams of this man standing at three different heights. In the first diagram, he's standing on the ground, which means his height above the ground is 0 meters. In the second diagram, the man is standing on a bench that is 0.2 meters tall, meaning that he is 0.2 meters off the ground. And in diagram 3, the man is standing on the top of a 25 meter tall building. Out of these three scenarios, in which one do you think the man has the most potential energy? If you said scenario 3, then you're absolutely right. Taking a look at the formula for potential energy, which is mass times gravity times height. Assuming that the man weighs the same in all three scenarios, then the mass is equal. The gravity should also be equal, assuming that he's on Earth in all three scenarios. However, the height is the one determining factor as it differs in all three diagrams. In the first drawing, the man's height is 0 meters. So if we plug this into the formula as the height, we don't even need to input the mass and the gravity, as anything multiplied by 0 is 0. Meaning that here he has no potential energy. In the second one, he's standing on top of a 0.2 meter tall bench. Let's say that his mass is 55 kilograms. We can plug that in, as well as the gravitational field of Earth, which is 9.81 newtons per kilogram, multiplied by the height of 0.2 meters. Here, kilograms cancel out, and we are left with newtons times meters. When we do newtons times meters, we get the joule, which is the unit we use to measure energy. Anyways, for our final potential energy, rounding to one significant digit, we get 100 joules. Moving on to scenario 3, plugging in the same mass of 55 kilograms, multiplied by the gravitational field of 9.81 newtons per kilogram, multiplied by the height of 25 meters. This gives us a final answer of 13,000 joules, or 13 kilojoules. Now these numbers don't really mean much by themselves, but if we compare these two numbers, based on their scenarios, we can get a better understanding of potential energy. Like we said before, someone would have a lot more potential energy standing on top of the 25 meter tall building than they would on the 0.2 meter tall bench, as the building is more than 100 times higher in the air. At this altitude, you would have a lot more time to fall and build up force so that you would have a harder impact with the ground. That could really be fatal. But if someone jumped off of this bench, they would already be on the ground before they have time to build up any substantial force. And so they hit the ground with only 100 joules of energy, which most people can absorb very easily. I feel like we're good on potential energy. Now let's move on to kinetic energy. First of all, kinetic energy is the energy due to the motion of an object. So for example, say you were playing volleyball with one of your buddies. To start, obviously you would have to serve the ball. You would wind up your arm backwards and then hit the ball over the air so that it can go over the net and the friend can receive it. When you hit the volleyball, you are giving it kinetic energy. And based on the mass of the ball and how fast the ball is going, we can determine the amount of kinetic energy that this ball has. The formula for kinetic energy is Ke equals 1/2 times mass times velocity squared. So let's say that the ball is 1.5 kilograms, and the speed of the ball was 20 meters per second. If we plug this into our kinetic energy formula, Ke equals 1/2 times 1.5 kilograms times 20 meters per second squared. This gives us a kinetic energy of 300 joules. Now what exactly does this mean? To understand that, we need to talk about the law of conservation of energy, which states that energy is never created nor is it destroyed. It is only transferred from one form to another. So going back to when you served the ball, you drew your arm back and then swung it forward, and then when your hand hit the ball, you transferred 300 joules of energy. so that it can pass over the net and go to the friend. Strategically, the friend would now want to volley the ball upwards so that he could slow down the ball and perhaps spike it back to you. When he volleys it upwards, he is actually absorbing most of the energy of the ball. Doing so, the ball slows down and gives him enough time to wind up even more energy and apply it to his spike to come back onto your side. And this shows how the energy is constantly being transferred and absorbed right underneath our noses. Finally, let's move on to mechanical energy. Determine the mechanical energy of a 540 kilogram roller coaster moving at 35 meters per second at the bottom of the first dip, which is 10 meters above the ground. Before we go into this question, you must know that the formula for mechanical energy is simply just potential energy plus kinetic energy, or in other words, mass times gravity times height plus 1/2 times mass times velocity squared. If we look at the question, we're given everything we needed to solve for mechanical energy. So plugging in each of these values, including the mass of 540 kilograms times gravity 9.81 newtons per kilogram times the height of 10 meters plus 1/2 times the mass of 540 kilograms times velocity squared, which is 35 meters per second. Plugging this all into our calculator, rounding to one significant digit, mechanical energy equals 400 kilojoules. Easy, right? In this question, we were given everything that we needed to solve for mechanical energy. But in other questions, we're not always going to be handed everything on a silver platter. Like next question, which will require a lot more thinking and problem solving. A 0.65 kilogram soccer ball is kicked straight up in the air. If the ball left the ground with a velocity of 21 meters per second, what maximum height did it reach? So let's say we were on the turf and someone kicked the ball upwards at a speed of 21 meters per second, and the ball, which was 0.65 kilograms, reached a height. We know that this is a mechanical energy question, but we can't just use the formula that we did last time, seeing as we would need every other variable besides height in order to solve for it. Bottom line is, we're looking for the height, and the only formula that I know that includes height is the one for potential energy. Potential energy equals mass times gravity times height. See, we have the mass as well as the gravity, but we would also need the potential energy in order to isolate for the height. We can come back to this later. For now, let's look at the formula for kinetic energy and see what we can do with that. See, kinetic energy only requires the mass and the velocity, which is exactly what we are given in this question. How can we make this work using the mechanical energy formula? Well, we know that mechanical energy equals potential energy plus kinetic energy. Remembering the scenario of the question, the ball was kicked up into the air and then it came back down. There had to have been a moment when the ball was on the ground, had no height, and was just starting to be kicked up by the player. In this moment, there was no potential energy, meaning that we can cross out potential energy entirely. So now mechanical energy equals 1/2 times 0.65 kilograms times the velocity of 21 meters per second squared, giving us a mechanical energy of 143 joules. Now, a little bit after the ball was kicked up into the air, and as it ascended, it started going up slower and slower until it reached its max height. For a split second, the ball remains in the air before coming back down. In that split second, the ball has no velocity, meaning that it has zero kinetic energy, and we can now cross that out of the equation. Now, inputting the mechanical energy of 143 joules from earlier, as well as the mass of 0.65 kilograms times the gravity of 9.81 newtons per kilogram multiplied by the height. And now multiplying the mass and gravity together with kilograms canceling out, this equals about 6.4 newtons. And now dividing 6.4 newtons from both sides, we isolate for the height. And for our final answer, rounding to two significant digits, the ball reaches a max height of 22 meters. If you've made it this far into the video, chances are you're learning a lot and enjoy the content. So if you don't mind, consider subscribing and dropping a like on this video, as it shows me that you like what you see, which helps me post more videos. Anyways, that's it for now. I wish you well, and hope you have a good day.